So we've talked about Spark Core and MLlib and also Spark SQL, which are two of the boxes built on top of Spark Core. Let's talk about those other two boxes, Spark Streaming and GraphX. We'll start with Spark Streaming. That's definitely the bigger of the two and the one that's more widely used. Spark Streaming is used for analyzing continual streams of data. So sometimes you don't just have this big corpus of data just sitting there that you want to analyze as a big batch. You have a continual stream of data that's always coming in all the time. And a common example of that is the problem of processing log data that's being generated by a website or a server somewhere, where that server just keeps on generating log data forever, and you need to monitor that thing in real time, or near real time at least. For example, maybe you need to keep a watch on error codes that are being generated, and you want to generate some sort of an alarm or page somebody or alert somebody when things go wrong. Spark Streaming can do that. The idea is to aggregate and analyze data as it's being streamed in at some given interval. And you can take that data from pretty much anywhere. I mean, at a low level, you can listen to data that's just fed in on some arbitrary port. So if it can talk to TCP, you can feed it into Spark Streaming. But you can also deal with integrations with specific systems to make things a little bit easier. For example, Amazon Kinesis, or listening to data that's being dropped in an HDFS file system, or data that's being generated by Kafka or Flume and other systems. These things all have APIs and libraries that you can use to talk to them directly and consume that data into Spark Streaming, crunch that data on your Spark cluster, and then take the results and feed it off to another stream or act on it in some way, store it in a database, whatever you want to do. It also has some nice features for fault tolerance. For example, it has a checkpointing feature that will continually store its current state to disk periodically. So that way, if your stream goes down or something goes wrong with the entire system, it can pick up where it left off automatically the next time you get it running again. So that's a good feature of Spark Streaming. These are complicated systems that involve, multiple systems that involve clusters of their own. So there's a lot that can go wrong. So that's an important feature to have. There's a couple of ways of doing Spark Streaming. The old way, that's the sort of the historical way of doing it, is using what we call a DStream object. And the idea of a DStream is that your stream is broken up into distinct RDDs. So technically, it's not a real-time stream of information with a DStream. You're getting what we call micro batches, just little snapshots of each chunk of data that's coming in, and you deal with each chunk at a time as a distinct RDD. A simple example of that is here on the slide. So this is a streaming word count example that comes straight out of the examples that ship with the Spark SDK. You start with the Spark context, and from there you can create a streaming context built on top of that Spark context. So the parameters on that first line indicate that we're creating a streaming context from a Spark context named SC, and the 1 means that we want to break that up into 1-second chunks. So we're going to be taking 1-second periods of that data, making individual RDDs out of each 1 second worth of data, and then processing those RDDs individually. So at this point, we're assuming that we're dealing with an individual RDD, and we're going to call an RDD called lines. It's going to represent a 1-second snapshot of a text file stream coming from the books directory. So text file stream just listens to a directory somewhere in a file system. In this case, maybe it's an HDFS file system where it has a directory called books. And it will just sit there monitoring that books directory, looking for new data being dumped into it over time. As new data comes in, within each 1-second interval, it will process the data that it sees within that 1 second and feed that back into your lines RDD here. From there, we can process it. So this line here is just some Python Spark code to count up the number of occurrences of each word within that RDD. So we start off with a lambda function that just splits each line into individual words based on the space character. We then map that to a count. So we have a mapping of each individual word to the number 1, and then we just add up all those ones together to get a final count of each word with reduced by key. So that's just keeping a count of all the individual words, how often they appear within that RDD. We then print out the results, and that's it. So those 4 lines of code are pretty much all you need to monitor a directory and keep a running count of how many words appear within a given 1-second increment of information. Once you have that, you do need to kick off the job explicitly. You just need to call ssc.start to kick off monitoring that books folder there and actually start the stream. And then you call await termination to just say, go and run this repeatedly forever until I say stop. That's all there is to it. So DStreams, again, are near real time. They're a micro batch API where we're dealing with chunks of data being streamed in continuously. But it's not technically real-time streaming. Okay, so some people find that a little bit off-putting, but it's kind of hard to find an application where a 1-second delay is really a big deal. So in a lot of cases, a DStream is a perfectly legitimate way to go, totally fine. And actually, the examples that ship with Spark itself for Python streaming all use this DStream API still. So, even though there is a newer version, a newer API that we're going to look at shortly, they still seem to be focusing on this in the Python world. Now remember, your RDDs with a DStream only contain that one little chunk of incoming data. Now, there are ways to aggregate data across multiple RDDs, multiple chunks, and actually keep track of things over time. We have something called windowed operations, where you can actually combine results from multiple batches over some sliding time window. So there are these functions like window and reduce by key and window that you could use to do that word count example over a sliding window, say the past hour's worth of data or the past day's worth of data, whatever you want, whatever window of time you want. So you can do that pretty easily with DStreams. You can also maintain any arbitrary state you want across these different batches that come in from your streaming data. Update state by key is what lets you do that. That just lets you keep track of some sort of state, some arbitrary information, across many batches as time goes on. So for example, if you wanted to keep a running count of some event or like the total number of lines that you've processed since the beginning of this stream, you could use update state by key to do that. And if you want to see an example of that in action, just navigate into the Python examples that ship with the Spark SDK. You'll see a file called stateful network word count that will show you how that all works. But the new way of doing all this stuff is called structured streaming. And the idea there is that instead of using DStreams and these distinct RDDs of data, we're just going to model our stream as a data frame that just keeps on growing over time infinitely. So this is kind of the new way of doing it. Python support for structured streaming is still relatively recent, but this is the direction that they're pushing their Scala customers in, and really people in general. This is kind of the newfangled way of doing streaming. The idea is that you just have a data stream feeding into this unbounded table, this unbounded data frame, and as new data arrives, it just results in new rows being appended to that input table. And there are a few advantages of this way of thinking. So one is because you can just think of it as a data frame and process it like any other data frame, your streaming code ends up looking a lot like the non-streaming code for dealing with the same kind of data. So it makes development a little bit easier. You can start with just a static data frame of data that's sitting on your hard drive somewhere, write all the code for processing and analyzing and doing whatever you want to that data frame, and then it's a very slight modification to modify that to deal with a stream of data instead. So it makes development a little bit easier. It's also useful because other systems within Spark are also moving toward data frames as an API. So MLlib, again, is also moving toward data frames as its primary interface. And especially in Spark 3, that's definitely the direction they're going. In fact, the RDD interfaces will probably go away sometime soon entirely. And the nice thing is that by using data frames as the API to structured streaming, we can interoperate more easily with things like MLlib. So it would be simple, for example, to take a streaming data source and feed that into a machine learning library algorithm using a data frame API. With that, let's look at an example and make it real and show you that this stuff actually works.